Welcome back to Stewart Science. I got a quick video for you today on the topic of velocity versus time graphs. So we've been talking about how we show motion with four ways. We talked about words, about diagrams, about graphs, and that's what we're going to do today. So the main graph we use when we're talking about constant speed is a position versus time graph. And like the name implies, in that graph we're showing where the car is over time. But we can also graph how fast the car is moving over time. Now, for a car that's changing speed, there's a lot more information that we can communicate with those graphs. But since we're just talking about cars or objects at a steady speed, this target is actually pretty easy. So like I usually do, I'll give you four examples and then I'll summarize it all at the end. This should be pretty fast. So here's the first example. If you'll notice when you look at these kind of graphs, you'll see the velocity of 0 is in the middle. Now, the other kind of graph, position versus time graphs, this 0 means the observer. On this specific kind of graphs, the velocity graphs, 0 isn't 0 meters or 0 centimeters, it's 0 meters per second. Now that's a speed. So this 0 in the middle here is not moving. So if you see a line that's getting closer and closer and closer to the 0, it's not getting closer to the observer, it's getting closer and closer to not moving. So that's what this is really, really hard to kind of wrap our heads around because we've done so much with position versus time graphs. To talk about velocity is kind of a shift in our head. So again, just want to reiterate one more time. 0, not the observer, not the reference point, it's 0 meters per second, which means stopped. If you had a line that was on the 0, that would mean the car or the object isn't moving. It's that simple. So if I look at this example, this one is at 2 the whole time, positive 2. At 1 second, positive 2. At 8 seconds, positive 2. At 25 seconds, still positive 2. What that means is the velocity is 2 meters per second forever, according to this graph, which means it's going away from the observer because it's positive. Now, this example is just a faster car. It's instead of at 2, now it's at 5, meaning our velocity is 5 the whole time, positive 5. So this one, if I was going to put it into words, would be the car is moving away from the observer because it's in the positive. It's a positive velocity, which means our position time would be going up. The car is moving away from the observer at 5 meters per second. Now, I could get a little tricky here and put something below the 0. And again, the 0 is not the observer. The 0 is not moving. So anything in this half, the top half of the graph, would be away from the observer. But now this line, the green line, is drawn at -3. If something is moving at a -3 meters per second velocity, all that means is going toward the observer at 3 meters per second. So if I was going to put this into words, the object is going toward the observer at 3 meters per second. You could say it's moving at -3 meters per second, but what that negative sign means is that it's going toward the observer instead of away. We use the positive and negative to communicate direction. And so my last example here is -1, 2, 3, 4, 5, 6, 7. So this example is a car moving at a constant speed because it's not going up or down, our speed is staying the same. Car is moving at a constant speed of 7 meters per second toward the observer. So I'm going to summarize here. Anything up in this half of the graph is going away from the observer because it's in the positive side of the graph. Anything down here in this half of the graph is going toward the observer because its velocity is negative. All of the examples that we're going to do are going to be straight lines across until we start talking about changing velocity. One more thing to take away from this: anything that's at that zero line means it's not moving. Anything that's near the zero line, so this zone or this zone, would be going slow because it's close to not moving. And then anything that's far away from the zero in those zones is moving quickly because it's far from zero. So anything at the line is stopped, anything close to the line is slow, and the further you get in either direction, both above and below the zero line, means it's moving fast. As always, this is Mr. Stewart. Keep learning no matter what.